Good morning, and welcome to Improving Your PLM Practices with MBSE. Today, we'll discuss how model-based systems engineering can improve your product lifecycle management practices. First, let's meet your presenter, Dr. Steve Dams. He's the president and founder of Spec Innovations. Steve participated in the development of C4ISR and the DODAS. He has his ESEP certification from INCOSE. He's also been involved with research, experiments, operations analysis, software development, systems engineering, and training for more than 40 years. Now I'll let you hear from Steve and we'll get started.
Thanks, Elizabeth. So here's our agenda for today. We're going to talk about what is PLM, for those who don't know, and then we're going to talk about what is model-based systems engineering. Then we're going to talk a little bit about how Innoslate can improve your PLM practices. So what is Product Lifecycle Management, PLM? So looking up definitions, you can see that PLM combines 5 distinct disciplines: systems engineering, program management, which includes portfolio management, product design, process management for manufacturing particularly, but also for other parts of the life cycle, and of course product data management. So many practices focus on 1 or 2 of these disciplines in depth and touches on the others. But to be successful, we know you need at least all these 5 areas, and that in fact you may need more to manage the products throughout the entire life cycle. So looking at the disciplines in depth, if you do a little further analysis, you can see that the 5 disciplines actually have a number of sub-disciplines and products associated with them. So here's an example in our spider diagram in Innoslate. We actually did this analysis, and we came up with 7 different major areas, plus all kinds of products and sub-disciplines throughout. So, for example, risk issues and opportunities is sub-discipline, but a bill of materials would be a kind of product capability you might want. So you'd have all of those with it. So a complete PLM tool really needs all these features and working together in concert to help you work more effectively and efficiently. Of course, Innoslate does have all this and more. So let's talk about the product life cycle. So there are many ways to visualize the life cycle, but they all have essentially the same phases and steps. My favorite way is this one. It's called the V diagram. And the V diagram lets you understand that you're starting from a current state of operations and maintenance, and you're going into a future state of operations and maintenance. This is where the world of process management really fits very well in the PLM disciplines. So a lot of what you're doing is actually working and understanding those processes and managing them to make sure they're effective and efficient. If you're doing actual development work, which is the systems engineering, your program management, your data management pieces, are all happening in this rest of the life cycle. So the architecture development, systems design, hardware software acquisition, integration test and operation test and evaluation, and transition into that future state of operations and maintenance. So here you are working through all that, and you notice that product design really fits into that bottom area, that hardware software acquisition cycle. We're actually just doing that kind of detailed design with things like computer-aided design, computer-aided and manufacturing side of it coming back up. So as we work through this life cycle, we need to make sure we can capture information in every phase and every step so that we can provide the understanding and documentation for the design development of any product. This really works with anything. It's a very general approach that you can apply across the board. So what's model-based systems engineering? How does it help us? So if you look for the definition of model-based systems engineering, here's one from INCOSE. Model-based systems engineering is the formalized application of modeling to support systems requirement, design, analysis, verification, validation, beginning in conceptual design phase and continuing throughout the development of later life cycle phases. But as you can see by this little graphic here, there are a lot of words that are associated with it. If you think about systems engineering, you hear about operational analysis, operations research, other things, systems analysis, characterizing different disciplines, all these things are part of systems engineering. And as you see that, all those are part of that whole life cycle as well, and the whole aspect of it. And if you look at the phases that it's talking about, requirements, design, analysis, verification, validation, that's the phases we were just talking about in the V. So it's really important. We highlighted the term formalized application because the problem that we get into in model-based systems engineering is a lot of people assume that you can do just drawings, and that's a good enough, and those are models. Well, a drawing is classically a model, but it's really not the kind of model we mean. I'll talk about more of that later. So what does this definition mean in practical terms? What does it mean for us? So what's MBSE? The disciplines include, but are not limited to, requirements analysis and management, functional analysis and allocation, physical architecture modeling, and that goes anywhere from the simple block diagrams to your detailed CAD drawings. Of course, verification and validation, and that includes simulation capabilities as well. We don't build anything anymore without having simulated it, seems like. And of course, in other words, all aspects of systems engineering. So both systems engineering and program management attempt to optimize cost, schedule, and performance, one for the system, the other for the program. So there's a big overlap there too. So the management parts of the problem actually have a lot of ways they can be system engineered. And so that you can apply a lot of the techniques that are in systems engineering to program management as well. The main difference between systems engineering and model-based systems engineering is the use of modern software tools to capture the data in a repository and convert this data into information through analyses and visualization. So what we're saying there is it's not just enough to do the basic systems engineering the way we always have, through building paper and creating paper output. The idea is to create a repository and have that model of the system be the ground truth, be what everybody looks at. And from that, you derive the analysis, analytical information, the visualization of the results, including your any final documentation. So what's a model? And I mentioned that formal modeling would require you to have specific specifications and ways that you want to have drawing standards. So you look at the middle there, that's your formal drawings. Unfortunately, most people are still in the ad hoc system engineering or paper-based systems engineering phases of the discipline. In both those cases, there may not be any formal modeling actually occurring. It may be just people drawing diagrams in Visio or PowerPoint that they think look good and kind of looks like a flow chart, doesn't meet the requirements of a specific flow charting methodology. So those drawing standards are things like the IDEFs. Those are an older standard that 70s and 80s were heavily used. Although still today we use the IDEF 0, which is probably the one most people are familiar with, but they had over 14 diagrams that were part of the IDEF set of standards. Then you go up to SysML, UML today, which are the, again, it's more of a drawing-focused standard. There's specific diagrams they're creating. There is an underlying ontology being developed for that, but it's still not there yet, and it'll be related directly to these drawings, not to an overall ontology that you might need to capture all the data throughout the life cycle. Another attempt at an ontology approach, a data-centric approach they call it, is what's called the DODAF Meta Model 2.0 or the DM2. That's another one where they're trying to look at the data side of it, and now that ontology turns out to be very focused on DoD terminology and approaches, and it's kind of narrow in a lot of ways, and it ends up being rather complicated at the same time. So it's sort of not exactly the best of all worlds, but it was designed by a committee for DoD, and so it makes sense in that domain to a certain extent. However, it does not deal with all the programmatic side of what you need to capture as well. And so it's missing things. Another approach to it was lifecycle modeling language, or LML, where that was being developed, looking at the whole life cycle and trying to simplify the ontology to a point where it could be very usable to a broad group of people. And I think that's been very successful. In that, there are some specific diagrams that are mentioned, that are suggested, as well as suggestions for all kinds of additional diagramming that could be doing just the common diagrams you're used to seeing. So in that standard, you can go see at lifecyclemodeling.org. It has that ontology and those drawings. The specific thing it was working towards, though, is the computable modeling standard, adding in the behavior diagram and talking about how that behavior diagram is executed. That's part of the execution logic. That's really where we want to go. We want to have a computable modeling standard that gives us the ability to combine the ontologies, the drawings, and the execution logics together. Right now, to my knowledge, LML is the closest thing we have to that ideal. So we need to move from today's state of primary ad hoc and paper-based approaches into this computable modeling standards so we can actually understand and get the benefits of what we need from models. So some of the benefits from the models are models provide traceability in many dimensions. In other words, all the different entity class relationships that you have, you can trace and see how they work together and operate together. Models can be automatically validated using simulation and rule checkers. That's a big plus because now I can make sure the models make sense. You can draw anything and actually have it not work. And many people understand that. Architects do the drawings, engineers check the drawings, contractors have to implement it, and believe me, there are changes all the way through those steps. Models can be interrogated. They can be looked at in different ways than what was originally designed. So you can understand it and you can respond to it and react to things. And then, of course, they can be reused. So if you've got a good model, why not reuse it and build from it? And, of course, they can be easily changed. That's another great benefit. So clearly, PLM relies on models to be effective. Model-based systems engineering provides a means for developing and managing those models. So how can Innoslate help you improve your PLM practices? So first of all, it can help you do a better job of systems engineering. Innoslate provides a complete systems engineering environment. Requirements view, functional and physical diagrams. Here's an example of our diagrams view. I'm currently showing 72 different diagrams that have been captured within the different types diagrams, again, over 25 types. Discrete event and Monte Carlo simulators are also embedded so I can execute the diagrams and make sure they operate correctly. The two execution diagrams are the action diagram you see on the top there, and then there's another set called activity diagrams, which are part of the SysML standard. We also have a test center to capture your verification and validation results and being able to put that together and then link it back to everything else, the requirements or the functional models or wherever else you want to link them back to. So another thing you can do is capture and relate program management information. You can model your management processes just like we've been talking about, so you can create a model like this. This is the behavior diagram, I would call it an action diagram in LML and Innoslate, and so the boxes are the functionality or actions. This diagram is all drag and drop, easy to work with. The parallelograms are the input-output variables, and so you can see the conducting R&D is going to result in an R&D plan and an R&D report, and then an approval to design going to the next phase. So these are triggers that then allow you to go to that next step and next phase. So you can actually model your entire management process this way. And of course, that's what they've been telling us to do for decades, since the 1950s. Deming told us that we need to focus on our processes and make sure we're working from them as part of management. You can also create a work breakdown structures. There's a cost entity that lets you capture that cost and then link them to these different parts of the model, and so the cost can actually be taken and simulated. You can capture decisions that have been made by your customers and other people as you've gone through, and that's a place also to capture your assumptions. You can also identify and manage your risks, and there's a risk chart for doing that as well. as the risk entity. We use a probability and consequence approach to risk, and you can see that you can capture what causes the risk, what mitigates the risk, and link those all together back to things. And then your Gantt chart and costs from the discrete event simulator are available, and of course also the Monte Carlo does the cost analysis as well. And for both simulators, you can get the Microsoft project reports. So also we do capture product design information. We can capture and visualize CAD files. That's one of the big things people talk about. But one of the most important things is to be able to take that information and use it to create assets. So you can decompose into assets by pushing the Create Assets button on the OBJ type of files. And from that, you'll get there's a hierarchy diagram showing that the shuttle is composed of these different pieces. That's how it was broken down. So that's what's in the drawing. Now I can take those pieces and relate them back to other parts of the database requirements, whatever else it needs to be done. Now, you can also capture artifacts from other or more detailed analysis. So you take your computational fluid dynamics analysis results, you can bring that in as an artifact, keep that all together, and then link it to the correct things that you care about. So it lets you do a lot of design management this way. And of course, developing the design specification from the models automatically. So actually, from the behavior diagram, the action diagram that we showed earlier, you can generate, with a push of a button, the actual specifications that are related to those diagrams. And develop test plans and capture test results as well. So now to the manufacturing process, how to better manage the manufacturing process. So again, modeling and verifying your processes using simulation. You can model states and modes, and in fact we have a state diagram as part of the SysML package that we have. So here's your state machine diagram that's available. So that's a good way to understand your processes. I prefer the action diagram myself, but a lot of people are very enamored with this diagram. It all works together. We don't care. You can work with however you like to work. We also conduct failure modes and effects criticality analyses using this approach. And we can interface with NPM tools. So if you have the manufacturing processing management tools, we have a way to hook our software development kit, our APIs to that, and they can interact together that way. And of course, if you want to do Zapier integration, if you're on the cloud, you can do it with we have 700 tools in the Zapier integration suite, GitHub, things like that. So now moving on to improving your project data management. Well, of course, certainly you want to be able to capture key attributes like part numbers, part descriptions, supplier vendor information, material data sheets, lots and lots of information. Well, we have many different models that do that. This is an example of a parametric model showing some of the kinds of data you might want to be capturing. We also have a class diagram that you can capture as well, that kind of information. And then you can relate those all, and you can extend the schema to meet your special needs and working with that. And of course, manage electronic files using artifacts. So here's an example of that, where we're showing the different artifact hierarchy that's created when you're working with different types of requirements. So here's your that's what we classically call a document tree. And so those kinds of things can also be captured and worked with in terms of your project data management. And of course, conducting your work breakdown structures I mentioned earlier and bills of materials. Again, since we can link everything between each other, between cost and schedule and performance, all links together into one place, it's very easy to construct these products that you do need when you're actually going out to bid something. So another facet that a lot of people forget about is real-time collaboration. You need to collaborate with your team members across multiple views. You need to be able to simultaneously show real-time user status, and you need to do group chats. And here's some examples of that. We'll show you this is our diagram where we have the chat box on the right, and it's indicating I'm looking at several objects that are in this database, and J and C are looking at two of those objects in some other view probably. And so this is chat's a way that you can then talk to J and C and see what they're doing and what they're up to and how to maybe resolve that. And project notifications are also available. We have the ability to automatically record in the dashboard what's changed, who's changed it, when did they change it. There's a hyperlink directly to that item, so you at ND, and you can then adjust it and change it as you need to. You can also receive email notifications of changes. So let's say you're worried about a particular thing like size. So there's a metric that I'm worried about, and I'm looking up for a particular product, part or something, and now I can track that and work with it together. And when somebody's changing it, I'll find out why they changed it, what did they do, and how does that affect what I'm doing. Also, you need to be able to scale to meet the need. So we've tested Innoslate Enterprise to 10 million objects and over 1,000 simultaneous users. Here's some of the data outputs for that. And of course, it scales extremely well. It's responsive even with these very large databases. It isn't just having the database capability underlying it. It's all, what do you do with that information? How do you load it? Do you do lazy loading? Do you do smart loading? Are you moving the data fast enough? Are you focusing in on the right things as you build the actual software? And of course, it's limited mostly only by the hardware you run it on. And that I should say also some of the software, like the browser, can limit you. Again, there's ways to, if you're running into problems, those kinds of things, please let us know, and we'll talk to you about how to help get around some of the problems you might run into. So easy to use. Overlays, we have overlays showing all kinds of different things within the tool. Your first time into a view, it'll point out what different things mean. We have rollover definitions. Here's an example of that. We have a number of different attributes that are kind of that define what's a good high-quality requirement. Well, I can't always remember the definitions of all of them, so I wouldn't expect you to. And so what you do is you simply go over into this entity view, you highlight complete, and it'll show you what the definition of complete means. By the way, if you don't want a description, you can do the same thing. It'll highlight that too. Those kind of built-in help capabilities that make it easier to use and easier to work with, easier to learn. Drag and drop, of course, we're using modern drag and drop everywhere we can. Makes it much easier to work with and move things around and create drawings particularly. There's a sidebar for attributes. You can, if you click on any diagram and you click on it, you'll get the attribute sidebar, and you can change them right there. And it's responsive. It's very quick, easy to work with. And of course, all this has been developed to the latest software, web software standards. It was designed for cloud computing from scratch. So in summary, PLM is critical for you to develop and manage your products throughout their life cycles. Model-based systems engineering provides a formalized methodology for conducting PLM, and Innoslate provides all the features you need to perform PLM. If you think we're missing something, please just let us know. Thank you for your time.